Okay, today we are doing Chapter 4, Section 3, Day 3. I've just titled this one, More Trig. It's just one more type of problem that you're going to see. And this problem, oops, I left off the theta. I should say tangent theta equals -2. So let me fix that. Tangent theta equals -2. That's your given. You're also given that sine theta is less than 0 and cosine theta is greater than 0. And told to find the remaining 5 trig functions. When I have to find all of the trig functions, I like to go ahead and set it up as my sine theta equals cosine equals tangent equals. And then leave some space and do cosecant, because sine and cosecant are the SC pair, so CSC theta equals. Cosine's pair is secant with an S and C, a C and an S. And then tangent's reciprocal is cotangent, COT. All right, so we have those set up. So if we know that tangent theta is -2 and tangent is y over x, I'm going to go ahead and fill those in too. So sine, we know sine is the y component over the radius. We know cosine is the x over the radius, and tangent is the y over the x. We could also write the reciprocals by just taking those and flipping them. R over y, r over x, and x over y. All right, so if we have that tangent equals -2, we can fill that in, but we don't know which one of these is negative. So I'm going to write the negative out front. And we had 2, I'm going to write it over 1 so we can tell what the values are. So we know the y value is 2 and the x value is 1, and one of those is negative, but we don't know which one it is. So to figure it out, we need to use this other given information before we can fill in the rest of all of this stuff. And we could do cotangent. We know that. It's going to be -1/2. But again, we don't know which one is negative, the 1 or the 2. So we can't do any of the other 4. So we have to figure it out. So we have to figure out we need to find a home for this tangent. Where does this tangent live is the question. So we need to find a home for this tangent. We know it lives on the xy coordinate plane. So we can sketch the xy coordinate plane. We know that much. And we see that sine theta is less than 0. That tells us if sine is less than 0 and sine is represented by the y's, tells us that y is negative. So if y is negative, we go to our coordinate plane, the y-axis. The negative y values are below the x-axis. So that means it cannot be where y is positive. So we can just cross off everywhere that y is positive, which is quadrant 1 and quadrant 2. We know our tangent does not live in quadrant 1 or quadrant 2 because it can't because of this condition. And then we have another condition, that cosine theta is greater than 0. Cosine tells us our x value. If it's greater than 0, x is positive. So we look at the x-axis. Our positive x values are to the right of the y-axis. So over here. So that means it's not on the left side. That's where x's are negative. Cosines are negative over there. So we know our tangent does not live on that side. All that's left is one quadrant, quadrant 4. So our tangent theta must be somewhere in quadrant 4. We don't know where, so we're just put it wherever you want, as long as it's in that quadrant. that's where our terminal side of the angle must be somewhere in that quadrant. We can build a little home for tangent, a little triangle home, by connecting back to the x-axis. Connect to x, and we can put our theta in that little home. Right triangle. So that's where our angle is. And if we know -2, and we put this over 1, and we know it's y over x, so if we look at the x value on the x-axis, that has to be positive, right? So this has to be x equals 1 because it's on the positive x-axis. Our y component is below the x-axis, so that must be the negative. Y is -2. And then we need to find the radius, because we need the radius for our sine and cosine values. So this is r equals something. We can use Pythagorean theorem for that. So 1 squared plus, make sure you use parentheses with your -2. -2 squared equals r squared. So 1 plus 4 equals r squared. So 5, and we can go and do the square root of 5 equals the radius. The radius is always going to be positive because it's a radius. You can't measure a negative radius. You just can't do it. So r equals square root 5. Now that you have the entire triangle built and you have values for everything, it's just filling in our table over here. So sine is y over r. Y is -2. R is square root 5. And then we can do cosecant once we have sine by flipping these. So square root 5 over -2. We can fill in cosine from our triangle. X is +1. R is square root 5. And then secant is flipping, is the reciprocal. So it's square root 5 over 1 or just square root 5, either way. So now we've filled in all of the values. We should also discuss rationalizing the denominator because it's considered bad form to leave a radical in the denominator. I don't always make you do that, but I do want you to be aware of how to do it. And whenever you have reciprocals, you want to get the reciprocal before you rationalize. Because if I were to rationalize this and then flip it, I would have to rationalize it again. So it's best to write your reciprocals before you rationalize. Only rationalize on your final answer. So when I rationalize this, I'm going to do it on the bottom, I have -2 over square root 5. The problem is that I have a square root in the denominator. So to get it out, I need to multiply it by itself. I can't just multiply a fraction one piece. I have to multiply both pieces, top and bottom. So top and bottom by square root 5. So that gives me, on the top, -2 square root 5. And then on the bottom I have square root 5 times square root 5. That is the square root 5 squared. Well, square root and squared are inverse operations, so they undo each other, kind of cancel out. So I end up with -2 square root 5 over 5 as my rationalized version of the answer. Now, I'm not going to require that you show me these in-between steps every time you need to rationalize because it follows the exact same pattern every time. What happens is this square root part moves to the numerator, and then you write the same value without the radical in the denominator. Every time. It works the same way. So I don't require you showing these steps, but if you have to rationalize, then make sure you do that. So -2 square root 5 over 5. So then this one, 1 over square root 5. Move the square root 5 to the numerator. And then write the value without the radical in the denominator, 5. All right, so these problems, your assignment is still page 251. You're going to do numbers 37 to 40, all of them. It's 4 problems. And numbers 43 to 57, odds only.